Okay. So, we have na-define na natin kung ano yung annuity. We had sample problems kung paano gamitin yung annuity, present work, and yung future work annuity equation. And then, we also have yung types ng annuity, yung annuity due, deferred annuity. Then, meron tayong perpetuity and amortization. Essentially, amortization is just annuity. Kasi pag sinasabi mong we should amortize yung payment mo, we're just gonna divide lang yung total outstanding balance mo into equal payments spread across equal interval ng time lang naman. That's it. Yun lang naman ibig sabihin doon. Then, meron tayong tinatawag na uniform gradient. Then, ginagamit ito, especially when you're conducting economic analysis, which involves receipts or disbursements that increases or decreases in a uniform amount. Okay? So, yung uniform amount yun, either exponential siya or constant yung increase po na yun. Pag sinabi natin constant yun, mayroon tayong tinatawag ng uniform arithmetic gradient. So, either nadadagdagan siya at a constant rate or nababawasan siya at a constant rate. Later natin i-discuss yung geometric. So, in this particular example, backtrack lang natin. Say, para ipakita ko anong sabihin po nun, say we have a maintenance expense on a certain machine that costs about 1,000 pesos at the end of the first year and is increasing at a constant rate of 5,000 each for the next 4 years. So, nag-increase siya ng constant 500 pesos for the next 4 years. So, how do we show yung cash flow diagram niya? So, remember, yung cash flow diagram natin dito is a visual representation how that 1,000 pesos is going to be now from the next 4 years. Okay? So, we draw yung cash flow diagram muna natin. And we know very well that on the first year, at the end of the first year, meron ka 1,000 pesos. And then, mag-i-increase siya ng 500 pesos each year. So, ito siya, 1,000, 1,500, 2,000, 2,500, and 3,000. Normally, we're looking for yung present value now. And from there, how do we go about this? Kasi kung regular annuity lang to, madali lang natin. Pero paano kung nag-i-increase ka siya? Actually, annuity rin siya. Kung makikita nyo dito, nag-i-increase lang naman yung cost every year by 500 pesos. Pero meron pa rin annuity dito. Kumbaga, yung annuity rin, yung may constant annuity siya of 1,000 pesos every year lang naman. It just so happen lang na nagdadagan siya ng 500 pesos every year lang. So, yan. And then, yung increase na yun, yung uniform arithmetic gradient na yun, ito siya. Which is yung constant 500 pesos. So, tatawagin natin siyang G. Okay, yun yung constant rate natin, 500 pesos dagdag na constant every year. Okay? And para malaman natin yung total present work nito, we have to get yung present work annuity, which we know already kung paano natin i-solve over the past few slides natin. But we have to consider yung G this time. Okay? And we can represent the equation just like so. This is yung pinaka-simple representation ng formula na yun. Pero let me break it down for you. So again, let's deal muna piece by piece. So here, pwede natin kunin mo na yung 1,000 pesos dito. Kasi yun yung constant naman all throughout ng 5 years na yun eh. All the next 4 years pala, sorry. 4 years nakalagay dito. Dapat 5 years to. Anyway, that's a minor error lang naman. So ito siya. And then pag ginawa natin yung annuity, ito lang naman yung ibig sabihin niya dito. So 1,000 pesos, 1,000 pesos, 1,000 pesos. Equal payments spread across equal intervals of time lang naman. So, very annuity. And we know yung formula natin dito. P, yung present work nito, yung annuity is equals to annuity, yung annual payments mo, times 1 minus close open parenthesis 1 plus I raised to negative n divided by yung interest rate. Okay? Or we could write it in this particular manner. Now, what about the G? So, we could represent naman to, since binawasan natin 1,000 ito, pag tinignan naman natin yung uniform gradient nito, it would look something like this one. Now, for the gradient naman, mga itsura nito, since tinanggal naman natin yung annuity, so dapat dito, makikita natin, wala siyang increase dapat dito kasi 0 yung G dapat dito. Since nagsimula pa naman yung increase after the first payment ng annuity na yan. So dito dapat 500 pesos, dito is yung 1,000 pesos, dito yung 1,500, so on and so forth. It should look something like this. And then makikita mo kung lalagyan natin ang algorithm, magsisimula yung G here, then 2G, then 3G, then 4G. So, dinagdag niya dito, 2G, so that's 1,000 pesos, so tapos plus dito, 3G, that's gonna be 500, so on and so forth. Wait, may error pala ako dito rin. So that should be, kaya naman pala, that should be 1,000 pesos lang naman. Okay? Yeah, there we go. And then from there, makukuha natin yung present worth ng gradient na yan. So how do we solve it back? And then ito siya, if you expand it further, it should look something like this, n minus 2 times g and minus 1g. And then the equation is, ito yung gagamitin na equation dito. So it looks like pa rin naman. It still looks like pa rin yung annuity equation natin dito, pero we can break it down further naman. So basically, in G is basically yung rate at which nag-increase at constantly on a per period basis or per payment basis. And then you multiply it 1 over I. Normally, G over I nakalagay sa mga books natin. And here, it looks like ito yung equation na nagagamitin for PG, and then multiplied by 1 plus raised to negative a kasi ito yung magiging present worth factor niya all the way back dito. Okay, and we can write the equation to, such as to. So, if anything, this is one of the new equations that I'm introducing pagdating sa uniform gradient naman. Okay? Bear in mind na hindi siya parating positive. This could go sideways naman. Pwede siyang decreasing. Especially kung decreasing naman siya at a constant rate. Okay? So, dapat, this one could also be, this equation could be also positive, but also negative, depending on yung case dito. Okay? So here's another representation para na-derive tong formula na to. So again, here's yung uniform arithmetic gradient nyo. So with that, we separate them by getting yung annuity muna. Ano ba tong constant rate? A constant annuity na to, equal payments over equal intervals of time. Malalaman mo yung first payment sa first payment sa first period niya. And then from there, we differentiate that. And then we separate the rest para matira na lang yung gradient graph dito, gradient cash flow natin. So we arrive at this particular equation. Then allow natin ng G, 2G, 3G, n minus 2G, and minus 1G. So from there, we just simply get yung present worth niya all the way back to 0. So here, G here is 1 plus I raised to negative 2. Then 2G here is a 1 plus I raised to negative 3, so on and so forth. Then from there, we just simply simplify them. And iba dyan magka-cancel out. Definitely magka-cancel out. Until you arrive in this particular equation. So you see there? So yeah. And then you simplify further, and you will have your present worth in this particular format. There. So ito, PG equals to G over I, or sometimes G times 1 over I, then 1 plus I raised to negative n minus 1 over I minus n, multiplied by 1 plus I raised to negative n. Okay. Let's try to use it para at least magamit yung kagad yung equation yan. So say meron kayong loan. It was to be amortized by a group of four end of year payments forming an ascending arithmetic progression. So doon pa lang, include na kayo na, okay, may uniform arithmetic gradient. Or if hindi naman sinabi yung arithmetic progression, anything that says about increasing at a constant rate, may fixed rate na increase on a per period basis or whether per month siya or per year basis. So in this case, the initial payment dito was to be made 5,000 pesos. And yung difference between successive payment is 400 pesos. So, ni-rephrase lang siya, pero malalaman mo dito, so yung difference daw between your first and yung next payment is 400 pesos. Yung successive payments is 400 pesos. So, yun yung constant rate of increase mo doon. And, but the loan was renegotiated to provide for the payment of equal rather than uniformly varying sums. So, if the interest rate of the loan was 15%, what is the annual payment? So, instead of ascending arithmetic progression yung terms of payment mo dito, they wanted it to restructure yung loan so that it's a regular annuity lang. So how do we represent that? Yung cash flow would look something like this. So we know yung initial payment is 5,000 and it will increase 400 pesos every succeeding year. No? So it should look something like this one. 5,000 in year 1, 5,400 in year 2, 5,800 in year 3, and then 6,200 in year 4. Okay? So recall, yung kailangan nating present work dito should be the sum ng present work for annuity and then yung present work for yung gradient. However, yung new loan structure should look something like this. Regular annuity lang. Okay. The problem is here, we don't know yung annual payment pa. But we do have yung data natin, yung first payment natin, which is 5,000. We do know yung increase ng payment, which is 400 pesos after yung first payment na yan. And we have yung equations natin ng present work annuity and yung gradient annuity natin. We're also given yung interest rate natin at 15%. So from here, we can definitely get yung present work from yung original loan structure. Saka natin siya gamitin pag nakuha na natin to, we can definitely substitute it here to get yung regular annual payments na. Okay? So how do we do that? There we go. So I hope you understood your logic na. No? So we are given everything here, including equations natin na pwede natin. We know yung equations na pwede natin gamitin. So what we can definitely get yung total present work po nito. And then from the total present work, we can definitely substitute it here sa new loan structure so to get us yung annual payment na required sa atin dito. So there we go. Okay. So we know yung present work net row. So sinubstitute ko na as one equation. So magiging A times 1 minus 1 plus I raised to negative n divided by I plus G times the whole open close bracket na to. 1 over I times 1 plus I raised to n negative 1 over I minus n multiplied by this one, 1 plus I raised to negative n close bracket. Okay? And then after that, kuha natin lahat yan. It should substitute natin mga values. It should look something like this. Pretty straightforward. And then you can solve it directly and you would get something along the lines of, so I just, solve it further pa. And the total present work is around 15,782.36 pesos. And from there, i-apply na siya natin para makuha natin yung annual payment para sa new loan structure. It looks like a simple annuity problem na ordinary annuity. So all we have to do now is just divide this, just like so. And you will get 5,528.01 or simply 5,528 pesos. Okay? Now, syempre, I mentioned earlier na if this is a constant arithmetic, constant progression, there's something called big growth rate naman. So the growth could be at a constant rate or could be tinatawag nating geometric. Okay? So, pag geometric gradient series, it's basically a cash flow series that's either increase or decreases by a constant percentage each period. So, a constant percentage. So, yung itsura ng cash flow natin, it doesn't look like a very linear. It doesn't look very linear. It's more a parabola. So to say, or half a parabola, basically. Okay? So it looks something like this. Ito yung cash flow. Ito yung increase and decrease, basically. So, again, ganun pa rin naman yung formula. Yung present work mo dito, total present work should be equal to yung regular annuity present work mo dito plus yung geometric gradient with one core difference rin. It could be positive and negative yung PG mo dito. Why? Kasi it could be increasing at a constant percentage each period or it could be decreasing at a constant percentage each period. Just be aware of that. So you're given another factor, another variable dito. So yung interest rate, and here yung G dito is yung constant percentage growth rate or the opposite of growth rate. So or decrease, basically. Okay, so ito yung basically yung pinaka-basic derivation ng formula and you will arrive with this particular equation. So ito yung magiging PG natin, yung geometric present work growth rate. Ito yung magiging present work geometric gradient natin and then here's yung respective formula niya. So magiging 1 minus the quotient ng 1 plus G, which is yung constant rate of growth or not growth. Yeah, so percentage of growth or in this particular case, kung pababa siya, percentage of, shrinkage siya or decrease basically, divided by 1 plus I, or yung interest rate natin raised to n, and then divided by yung interest rate na meron tayo for the problem, and then interest rate for the period minus yung growth rate or yung shrinkage rate basically, or reduction rate basically. Whereby yung formula natin dito is, in this particular case, our growth rate is not equal to increase to our interest rate. Okay? So makikita niyo yung definition of terms. Dito yung constant rate of change, whether increasing siya or decreasing. So that's it. Yung constant rate of change from the first payment period in decimal form, by which the cash flow values could either increase or decrease, and the gradient can be positive or negative. So yung A1 naman dito, for this particular graph is yung first payment, and then initial cash flow in year 1 of the geometric series or whatever first period you have. And then PG here is the present worth of the entire geometric gradient series. Okay, so we're just gonna call it present worth of geometric gradient. Okay, if it's increasing at a constant rate of change. So we can simplify. We can derive by yung formula na yun. Here we have yung graph. It's not supposed to be linear, but more of a parabola or hyperparabola. So there goes yung first payment natin, yung A, and this is yung second payment. So alam mo na mayroong annuity pa rin dito. And you derive the equation further, and we would arrive pa rin with this particular formula. So yung tinatawag natin dito is geometric gradient series present worth factor. Just for your information lang naman yan. Okay? With your interest rate not equal to G. But there's also a case where in your interest rate, your growth rate, or whatever your rate of change na yan, whether increasing or decreasing, could be equal to your interest rate trend. So the formula would look something like this one naman. When your interest rate is equal to your rate of change naman. Yeah. Rate of change sa geometric gradient mo. Okay? So here's the formula for not equal to your rate of change. And here's the formula for when interest rate is equal to the rate of change on your geometric gradient series. Let's try answering a problem. Here's a problem from the book of Leland. So here we have a coal-fired power plant naman has an upgraded emission control valve. And this modification, the modification costs about $8,000 and is expected to last 6 years with a salvage value of $200 by the end of its year. The maintenance cost is expected to be high at $1,700 the first year, and it will increase in the foreseeable future for 6 years by 11% per year thereafter. Determine the equivalent present worth of the modification and maintenance costs at 8% per year. Okay, so yeah, there we go. So the maintenance cost and the modification, that's just one. So that's going to be $1,700, and it will increase by 11% every year. The interest rate given to us dito is 8%. So I want you guys to not be confused in percentage dito. I want you to make sure to have yung distinction ng growth rate dito, yung rate of change versus yung interest rate per period basis. In this case, per annual basis siya. So let's draw muna yung present worth, yung cash flow natin dito. Okay, we know very well na meron kang first cost na 8,000 pesos, and then meron kang salvage value at the end of 6 years na $200. So it should look something like this one. And then from there, we want to know what's the present worth of the modification and maintenance of cost. So you're trying to estimate dito eh. So you know na gagastos ka ng 8,000, then how much more do you need now? What's the present value now? So that you can cover yung modifications and maintenance costs. So nakalagay dito, it's expected to be high. So you're forecasting for the future. So you have to determine the budget now. So you want to know yung present value now so that you can cover yung maintenance and yung modification cost na yan. So that's our problem. That's our required dito. Okay. You know na yung first cost, it's gonna be high. It's gonna be $1,700 in the first year. But it's just gonna be increasing 11% every year. So it's gonna look something like this. So 1.11. So basically, it's just looking in future worth lang naman to 1,700 times 1.11 raised to 1 Dito from this end, 1,700 times 1.11 raised to 2 kasi 1, 2, diba? And so on and so forth. Ito, 1,700, 1.11 times 3 kasi 1, 2, 3. Okay. And then, you would reach this one. Yeah, so makikita nyo dito sa half a parabola siya, okay? So recall, we have this particular formula for determining yung PG natin. So, which is basically this one. We know this particular formula. We know yung annuity niya dito. So, in this particular case, we're not given yung gradient na yan. So, this is still yung annuity. We know yung annuity natin dito to be 1,700. It's gonna be fixed. Yung growth rate lang and yung kaakibat yung cost is indifferent lang. And if you're writing yung formula na to, so we know to get yung present worth, so we have yung total present worth. So, meron na tayong 8,000 kaagad dito. You know, that's the current value now. It's gonna be negative 8,000 lang naman. Based dito sa equations natin, okay? Then, you know na may positive $200 tayo, which we will return sa present worth. So, ito yung $200 in the foreseeable future. We have to know yung present worth value niya now at 8%. And then, of course, we have to apply yung PG, yung present worth of the total gradient, geometric gradient series natin dito. And it will look just like so. There we go. We apply equations natin. So, it's negative because it's going outward. It's a cost on the plant manager's perspective. Okay. Yeah. Actually, it doesn't matter naman kung negative naman. Okay. So, at least from this perspective, kailangan equal lang naman. Okay. And then $200 dito. And then, so, in negative $8,000 minus yung 1,700 times, substitute natin yung mga known values natin dito. And then, we have 200 times 1.806, negative 6. And we will achieve this one. And we will have negative 17,899.03. It's only negative because ibig sabihin nito is just it's a cost really. It's just cost sa kanya. Okay? And we have to, if you do it in reverse, you have to minus yung $200 because that's not accounted for pa. Okay? That's something you will only gain after you sell yung emission control valve na yan in the future. So if you do it in reverse naman, pataas lahat to, that's fine. Yung 200 naman yung magiging salary kasi you will sell it naman from the perspective from your end naman. Here kasi gagastos ka pa. So you wanna know how much you need to cover it. Okay? So yung gagastusin mo in the future, in the foreseeable future is around $18,000 dito. Or to be exact, 17,999.08 cents. That's about it for Annuity, and hopefully you're able to answer your problem sets and make sure to pass it before the deadline. Thank you.